This is Dr. Mears, and today what I'm going to be doing a video on is the Do, Check, and Correct page 238, number 2. I actually assigned page 238, number 2, and page 241, number 8. I am not going to do number 8 because the actual steps for page 238, number 2 are exactly like page 248. 41, number 8. So I am just going to do this one. So hopefully if you can follow along and understand number 2, then you will be able to do number 8. So number 2 is from your book, which stated we want to see if there's a independence between hair color and eye color. And we're going to go through these steps that are listed here. It's about time. He was interested in finding out whether natural hair color was related to eye color. He surveyed all the students at his school. He observed, notice they even say observed, data in the table below. We need to perform a chi-square test at the 10% significance level to determine if hair color and eye color are independent. They actually here, they're giving you the null hypothesis here. So let's see. We will run through these. Part A says state the null hypothesis and alternative hypothesis. I am going to put the book aside. I will read the steps as we go through. So what I did here, number 2, I always write down the observed table. So here's what they gave you. They actually gave us the totals as well. So thank you. We didn't have to calculate them. Thank you, book. So part A, we needed to write down the null and the alternative hypothesis. Our null hypothesis is here. H sub O, hair color and eye color are independent. Please notice, they gave you that sentence in the problem. So that is our null. All our alternative to that null, H sub A, hair color and eye color are not independent. So the null, this one is always R, and the alternative is always not independent. So that was part A. This is just like our step 1 for the steps that we went over the other day. All right, part B in the book says, find the expected frequency of a person having blonde hair with brown eyes. I wrote that sentence down here because that's what we're looking for. They just wanted one of the expected frequencies, just the one with blonde hair and brown eyes. What I decided to do, because they're probably going to need it, is do the entire expected frequency table, which is here. I'm going to run through this relatively quickly because what we need to do is multiply each row total by the column total and divide it by overall. So up here, remember, these are our row totals, these are our column totals, and this is our overall. So for each one of these entries, we have to find the row total, multiply it by the column total, divide it by the overall. So let's look at brown black eyes with black hair. We have, this is 35, so we look, row total is 90, column total is 52. So we're going to do 90 times 52. Our overall total was 227. Did we multiply and divide? We get 20.6. The next one, brown and black eye color with brown hair. We see row 90, column 90, so it's going to be 90 times 90 divided by 227, which is 35.7. And the last one for this brown black eye color is going to be 90 times 85 divided by 227. You have to do that for each and every entry. Once you have that, this is your expected value, expected frequency table. And now we can actually answer the question. We need to find the expected for blonde hair and brown eyes. So let's look, blonde hair, brown eyes. So that's going to be 33.7. That's our answer. We write it down, 33.7, and we circle it. So that's our actual answer, but we did do the entire table, which is a good thing because I know we're going to need it. Okay, let's move on to part C. Part C says, write down the number of degrees of freedom. Now, degrees of freedom is the total number of rows times the total columns. You cannot count the total column and total row. So what I mean by that is we have to take out these totals. So we are not looking at that. All we're looking at is the raw data. There are 1, 2, 3 rows and 1, 2, 3 columns. So just where that original data is, no total involved. So we have 3 rows, 3 columns, and so it's going to be a 3 by 3. So we're going to look here. 3 minus 1 times 3 minus 1. 3 minus 1 is 2. 3 minus 1 is 2. Multiply them together, we get a degrees of freedom of 4. Next, write down the chi-squared value for this data. Here is the chi-squared. We have to do the observed minus the expected squared divided by the expected for each and every entry. So we have to go back here. So the first entry, 35. Here's our observed value, 35. Wrote it down, 35, minus its expected value, same place right here, expected value, 20.6. Minus 20.6 squared divided by 20.6 plus, let's go to the next value, 43. So here we have our observed for that one. Let's go down and find its expected. Here's the expected value, 35.7. So now what we have to do is 43 minus 35.7 squared divided by 35.7. You have to do that for each and every entry in that table. Once you put those numbers in, you have got to show this work. I always like to put my numbers in to make sure my numbers are lining up. I've put them in correctly, and I'm checking them with the table to make sure I didn't miss anything. Once I have that done, I like to transfer each one of those entries into a decimal. Notice I did round to the second decimal place. I like doing that instead of 3 significant figures here because it helps us get a more exact chi-squared value. So what I did was 35 minus 20.6 squared divided by 20.6. And I actually put it in my calculator. I will show you just like that. So I did parentheses 35 minus 20.6. I squared it and then divided it by 20.6. Just like that in my calculator, if you can see that okay. And then I press enter and I got 10.0661942 and I went to 10.67, 10.07, excuse me for the little mistake, 10.07. And so for each and every one, I did them separately. And then I double checked to make sure that these numbers were correct. Notice that one right there, I made a little mistake. I double checked it before I wrote it down and I fixed it. After I have each and every decimal, after I calculated each and every one of these out, I then add them up, which is a chi-squared of 44.3. This is the one that I did to 3 significant figures because it asked me to write this one down. This one was actually 44.31, but 3 significant figures, I went to 44.3. So it originally was 44.31, and I rounded correctly to 3 significant figures, which gives you 44.3. So when it asks you to write down the chi-squared value, give that one to 3 significant figures. All your other work, you can go to more than 3 significant figures. Next. It says the critical value is 7.779. So they gave you the critical value here. Usually we would have to look up our degrees of freedom and our significance level of 10%. And we would look for our significance level on that green sheet. We would actually look up the value 0.100 on that sheet with the degrees of freedom of 4. We don't have to do that here because thank you again, book. They actually did it for us. So for part E, they said using the critical value or the p-value, we have not touched upon p-value yet. Comment on your results. So we are going to use the critical value. I do abbreviate that as CV sometimes. That's why I put the little CV up here. So let's look to see what happens. So for step 4, when we did our steps, the last lesson, it said to compare the chi-squared, and remember, this has to be in this order. Chi-squared has to come first, and then your critical value when you compare. So I write those 2 things down first. Underneath chi-squared, I wrote my 44.3. Underneath my critical value, I wrote 7.779. In comparing them, I see that 44.3 is greater than 7.779. When it's greater than, you reject H sub O. That's what it says in our sheet. It is in the rejection region because this is substantially bigger than my critical value. So let's see what I would write as a sentence. The chi-squared value of 44.3 is greater than the critical value of 7.779. Reject HO. Hair color and eye color are not independent. Now, when we reject our null hypothesis, we're actually going back to this first part, this first step. This is the null hypothesis. We're rejecting this. This is out. Once we reject that, we say that we now have evidence to support that they're not independent. So we have evidence for this. And this is where I got the sentence here. Hair color and eye color are not independent. So once you kick your null hypothesis, your H sub O out, you do have evidence to support that hair color and eye color are not independent, and that's what you write. Hopefully this helped. Please ask questions, go back, pause, try number 8, same steps, you should be good to go. Thanks. Bye.